Hello, I would like to give you all basic differentials rules, show you some examples, and then we'll solve them with a Python script. So the first rule is a sum rule, which tells you that the derivative of the sum of two functions f and g will equal sum of the derivatives of this function. So y prime will equal f prime plus g prime. The second rule, power rule, which tells you that if you've got a function y equal x power n, then the derivatives y prime will equal n times x n power n minus 1. So on the basis of these two examples, we can make the derivative of the polynomial function. So if you've got y equal 2 times x cubed minus 4x squared plus x minus 8, for example, then the derivative of this function y prime will be equal 2 times 3 equals 6, so 6x squared minus 8x plus 1. The next rule, product rule. If you've got a product of two functions, the derivative of this product will equal, so the y prime will equal f prime x from x times g from x plus f times g prime x. Next rule, rule number 4, quotient rule. If you've got one function divided by another function f divided by g, then the derivatives of this equation y prime will equal. So let's draw the fraction line, and the denominator will be equal to g squared, and the numerator will equal f prime times g minus f times g prime. So we can write some examples. So if y equal 1 divided by x squared plus 1, so let's make assumption f will equal 1 and g will equal x squared plus 1. And the derivative y prime will equal, so let's draw the fraction line first, and then numerator will be minus 2x, and the denominator will equal x squared plus 1, and everything is squared. Last rule, chain rule. If you've got one function from another function, for example y equal f from g from x, then the derivative of this function y prime will equal f prime from g times g prime. Or in Lagrange writing, it will be df over dj times dj over dx. And let's do some example. For example, if y equal, let's say, sine from 3 sine x squared, then the derivative will be, derivative of sine is cosine, so it will be cosine from 3x squared times the derivative of the g function, which is times 6x. So let's find analytical derivatives for this function with Python script. First of all, we need to import SymPy library with using sp for shorter. Then we declare x as a formal variable for SymPy. Now we write this function for calculation. So y1 will be 2x cubed minus 4x squared plus x minus 8. y2 is equal 1 divided by x squared plus 1 and y3 is equal sine from 3x squared. So now let's calculate derivatives with SymPy. So we use function diff. Its first parameter is a string with our function, and second is formal variable for as a derivative. So now we can just copy this string for make 3 lines. And now let's print out the results with f line. So we will print out our function and our derivative. So now let's copy this line and make it's changed for second and third function. And let's run it now. So as you can see, first derivative is 6x squared minus 8ax plus 1. Second derivative is minus 2x divided by x squared plus 1 squared. And third derivative is 6x cosine 3x squared, which is exactly as it should be.